Here we've got two variables, n and k, and we were told right from the get-go that they're positive integers. And that gets me thinking we can probably use test it. The prompt itself has a psychological component to it, and it asks, is the square root of n plus k greater than 2 times the square root of n? So it's a yes-no question, but most people freak out when they see radical signs, and that's actually why the GMAT puts them here. If you freak out when you see a math symbol, then business schools don't want you. They want you to stay calm. This is a question with a couple of variables. You've got a pretty strong tactic in Test It to use it. And since you've done the Empower Mini Clinic for radicals, you know that there's only a couple of rules that the GMAT will base this question on. You're going to use Test It, you're going to do some arithmetic, and you're going to keep track of the results. Stay calm, write everything down, and you'll be able to answer this question. Looking at it, though, it seems to me that the hinge point is the k. If the k is gigantic, then the left-hand side will be bigger than the right-hand side. But if the k is really tiny or something close to n, then the left-hand side won't necessarily be bigger than the right-hand side. So we've got to keep that in mind. The issue is how close can we make the k to the n? Depending on what happens there, we'll either get sufficiencies or insufficiencies. So let's take a look at fact 1. It says that k is greater than 3n. So let's talk about test it. The easiest number I can pick for n is 1. The k has to be greater than 3 in this case, so let's choose 4, and let's plug these values in. The question now asks, is the square root of 5 greater than 2 times the square root of 1? Yes or no? Now, the square root of 5 is something you can estimate. Because the square root of 4 is 2, the square root of 5 would be a little bit bigger than that, so I'm just going to estimate that as something greater than 2. The right-hand side is 2 times the square root of 1, and the square root of 1 is 1, so it's essentially saying, is something greater than 2 greater than 2? And that's a pretty obvious yes. So our first test case is down, but I want to try another. How about we pick n equals 2? In this example, the k would have to be greater than 6, so let's pick 7 and plug those values in. Now we're looking at this. Is the square root of 9 greater than 2 times the square root of 2? Yes or no? Well, the square root of 9 is easy. That's 3. 2 root 2 might seem a little strange, but if you've done the Empower Skills clinics, you know perfect squares all the way up to 15. 15 squared is 225, so 1.5 squared is 2.25. By comparison, the square root of 2 is less than that, so the square root of 2 has to be something less than 1.5. So what this is now asking is this: is 3 greater than something that's less than 3? And the answer there is clearly a yes. Now at this point I'm going to stop. I'm not going to do any more tests, and here's why. We made the k as close as we could to the n. If I make the k bigger, the left-hand side is just going to get bigger, but the right-hand side will stay the same. That'll keep giving me yes answers. I'm comfortable calling fact 1 sufficient on its own because of the rules of math. So let's knock out B, C, and E, and let's go on to fact 2. It says n plus k is greater than 3n. So if I combine like terms, we'd have k is greater than 2n. And let's go about using test it again. If n equaled 1, k would have to be greater than 2, so how about we choose 3? If we're using n1, k3, the question asks, is the square root of 4 greater than 2 times the square root of 1? And that means, is 2 greater than 2? Well, no, it's not, so that gets us a no. But we can keep that n equals 1 and use anything else for k, including k equals 4, or k equals 100, or k equals 1,000. And with that example from the first fact, we'd get a yes answer. We already did all that work. You can clearly see that fact 2 is insufficient. So it gets a little I, and the final answer is A. Truth be told, this question won't kill you if you get it wrong, but it's 2 variables, it's a great test-it scenario, and in about 2 minutes, maybe 2 minutes and change, we got the correct answer. Business schools are infinitely interested in seeing if you can solve little puzzles, if you can stay grounded and calm, do some work, and prove that you're correct. And that's why Test It is so useful in the quant section, because while you could do math here, it's not really a math question. It's a comparison question. And in the end, I didn't do a lot of calculations. I just came up with some possibilities, proved what was possible, and proved what was not. And that's one of the skills you need if you want to break into the 700 plus club. The 90th percentile is a group of people who are calm and organized and rational. They realize they don't have to do a lot of math to answer questions. And it's something that a lot of people aren't comfortable with, unfortunately. So if you got this question wrong, it's not the end of the world. but you got to get comfortable with the idea that variables gives you opportunity to use test it, and you got to be using it on at least half the questions if you want that big score. Go back, do this question again in a week or two. Go back and watch this video again as many times as you need to remember the tactics, because this is killer stuff. And if you want that elite level score, you're going to have to work like crazy on test day to get it, but the steps to earn it are actually pretty straightforward. You can put them on the pad, just stay organized, and you'll get the score that you want.